Assalamualaikum and hi everyone. Before we start our presentation, let me introduce my team. First of all is Dinesh. The metric number is 01DAD 24F1083. The second is Jeremiah. The metric number is 01DAD 24F116. The third is Yugendeshwaran. The metric number is 01DAD24F1112. And last is me, Danish Irshad. My metric number is 01DAD24F1081. Before now, let me start about. We choose the topic 6, that is isolation procedure before maintenance of electric and hybrid vehicle. Before I start, let me introduce about electric vehicle EV and hybrid electric vehicle HEV. This vehicle use high voltage system, typically 100 volt and 100 volt to 800 volt, which are much higher than conventional vehicle. This system power component such as the battery pack, inverter and electric motor. Due to this high voltage, improper handling can result in serious injury, electric shock or even death. Therefore, isolation procedure must be strictly followed before any maintenance or repair work is carried out. The importance of isolation procedure have several reasons. First, they protect the technician from dangerous electric shock and arc flash hazard. Second, they prevent unexpected activation of electrical component. Third, they reduce the risk of fire, explosion or short circuit. They help maintain the integrity of sensitive electronic system. And last, they ensure compliance with safety regulation and industry standard. Without proper isolation, maintenance work on EV or HEV can be extremely dangerous and life-threatening. Now I continue with identification of high voltage component. Before performing isolation, technician must understand and identify the high voltage system component. First, high voltage battery pack store electrical energy. Second, inverter or converter convert DC to AC power and control power flow. Third, electric motor drive the vehicle. Fourth, high voltage cable. Usually the cable is orange color for easy identify. And last, power control unit, PCU. Recognizing this component help avoid accident contact with high voltage area. And last for me, hazard in high voltage system. Working in EV or HEV system involves several hazards. First, electric shock due to high voltage. Second, arc flash which can cause burn and explosion. Third, thermal hazard from overheated component. Fourth, store energy in capacitor even after shutdown. And last, battery related risk such as chemical leak or fire. Understanding this hazard emphasizes the need for proper isolation procedure. Now, I will pass to Jeremiah.
Now, let us first take a look on the steps we have to follow for maintenance of a high voltage system. So the first step is vehicle shutdown. we have to turn off the ignition of the vehicle completely, and then we have to remove the key or key fob from the vehicle and ensure the vehicle is in a park mode, and we have to wait for at least 5 to 10 minutes for the capacitors to discharge. This step ensures that the system is no longer actively supplying power. And next, step 2, we have to disconnect the 12V battery. We have to disconnect the negative terminal of the battery first, followed by the positive if it is required. We have to disconnect the 12V battery because it controls relays and electronic systems. By disconnecting the 12V battery, it prevents the activation of the high voltage circuits. Following that, we have to perform step 3, which is isolating the high voltage battery. We have to locate the safety plug and carefully remove it according to the manufacturer guidelines. And we must use insulated tools for this and store the plug safely away from the vehicle. This physically breaks the high voltage circuit, stopping current flow to the high voltage system.
Hello, my name is Dinesh. My metric number is 01D8024F1083. And let's look at the step 4, which is lockout and tagout. Apply a lockout device to prevent reconnection. Attach a warning tag such as do not operate. Inform all personnel that maintenance is ongoing. Loto ensures that no one accidentally restore power during maintenance. Next is step 5. Verify zero voltage. Use a digital multimeter or voltage tester. Check the voltage at key point in the system and confirm that voltage is 0 volt. That means zero energy state. This is the most critical step before touching any high voltage components. And the next one is personal protective equipment, PPE. Technicians must wear proper PPE. Insulated rubber glove, red for high voltage, and safety goggles or face shield, and insulated safety shoes, and flame resistant clothing. PPE provides additional protection against accidental electrical exposure.
My name is Igneshwaran Anaralaki Bhaskaran. My matrix number is 01DAD24F1112. The next one is safe working practices. During maintenance, use insulated tools only. Avoid wearing metal accessories like rings and watches. Work in a dry and clean environment. Follow a manufacturer and safety guidelines. These practices reduce the risk of accidents during maintenance. The next one is reconnection after maintenance. After completing maintenance, reinstall the service plug, reconnect the 12-watt battery, remove lockout or tagout devices, start and test the vehicle system. Ensure the system is functioning properly before releasing the vehicle. Consequences of ignoring isolation. If isolation procedures are not followed, severe injury or fatal electric shock can affect. Fire or explosion hazard can happen. Damage to expensive vehicle components, and legal consequences and safety violations. This highlights the importance of strict safety compliance. Conclusion. In conclusion, isolation procedures are a fundamental safety requirement when maintaining electric and hybrid vehicles. By following proper steps such as system shutdown, battery disconnection, high voltage isolation, and voltage verification, technician can ensure a safe working environment. Safety must always be a top priority to prevent accidents and ensure effective maintenance. That's all. Thank you.